Okay. So hi everyone. As I said, my name is Thomas. I'm a big data engineer lead at Radius, and today we're going to discuss how at Radius we created a graph of all US businesses in Spark and Scala. And I have a confession to make. 9 months ago, I didn't know much, and actually nobody at Radius knew much about Spark and Scala. We were a Hadoop and Java shop. And so this talk is really about how we moved from Hadoop and Java towards Spark and Scala. And let me start right off with the key takeaways I would like you to go home with. The first one is Spark and Scala have an amazing synergy. And if you consider using Spark, I encourage you to use it with Scala as opposed to Java. The second thing is, if you're a current Hadoop user, you might consider transforming your next big Hadoop refactor into a migration towards Spark and Scala. You might get a lot more out of it as what you get today with Hadoop and Java, including more performance, more scalability, more capabilities out of the box with Spark, but also you might notice that it is a new project in Spark and Scala is easier to maintain. You will ship feature faster, and generally speaking, you can have more engineers working on that project. So a couple of words about my company and why we are trying to create, or why we do create this graph of all US businesses. Radius helps marketers discover new segments, acquire new customer, and measure success. And it does that by providing a big, a data science engine that does powerful predictive analytics and segmentation based on our customer CRM data. Now, Radius was founded in 2009. We are over 100 now. We recently closed 50 million in Series D. That's over 125 million total. And our customer includes Staples, American Express. I mean, customers that need to sell to a lot of customers and for which CRM data is obviously critical. We are very heavy in data science and big data technologies. Now, back to the business graph, what do we need it for? Remember that what we're trying to do is enable CMOs and VP of sales find the segments where they will be performing well. And one naive approach, I would say, would be to do predictive analytics and segmentation on their raw Salesforce data. Unfortunately, that is only going to be as good as their CRM data, and as you might know, CRM data is not very good because it's not up to date, it's not accurate, and it's usually very poor in terms of signals. And so the way we approach this problem at Radius is 3 steps. First step, we create that list of businesses in the US, that graph, and we try to keep that graph up to date. So that means weekly builds, accurate and exhaustive, and with as many features as possible, like what's the revenue of this company, what's the headcount of this company, is this company on Facebook, is this company on Yelp, a lot of things that you wouldn't find in a typical CRM. And so really this is what I'm here to talk about, this list, this graph of businesses. Then step 2, we match our customer data with that list. And now step 3, we do all our predictive analytics and segmentation on our version of the customer data, which is richer, which is more accurate, which is more exhaustive. And all of a sudden, by construction, the accuracy we get on predictive analytics and segmentation is way higher. So that works if we manage to build this graph of US businesses, right? And so I'm going to talk to you about how we went from doing that in Hadoop and Java and how we migrated that in January to Spark and Scala. So before, in the Hadoop and Java world, this is how we would do it. So first, as an input, we had 500 million records. Those records would be things we crawled on the web, data that we paid for, public record data as well. And those 500 million records represented roughly 20 billion data points. And so first we would standardize it, and then we would group records that we think represented the same business together and created a business out of each group that represented roughly 15 million businesses. This approach worked, but it had several limitations. The main one was that our code base was large and with a steep ramp up. We were using cascading, and cascading helped a lot, but even so, it was challenging. And only seasoned Java developer could really work on that project, and that is after, as I said, a long ramp-up time before they could actually contribute anything. The project had a high upkeep, maintenance cost, and we were not shipping as many features as we wanted. And so we knew that a very large refactoring was looming. At the same time, we were looking for two other things. We knew that instead of just grouping records together when we think they are about the same business, we wanted actually to be able to model the relationship between those records. And so we started looking around for a graph processing framework. Also, we were imputing, classifying, doing regression on more and more data points to improve our graph, our list. And we know that we also needed a machine learning framework. And so very naturally, well, we looked around and here was Spark. That was December. And we thought, hey, let's give it a shot. And so we started to do a migration pilot. And what we found out was very nice. First off, Spark brought a lot to the table and delivered pretty much on all the promises. It delivered performance, it delivered scale. We had no problem at all processing the data that we were already processing in Hadoop. And it also delivered with GraphX and MLlib, which are really outstanding libraries. And since Spark has seamless connectivity with your Hadoop ecosystem, we didn't have to jump through hoops to get started. We would easily read from S3 right to S3. That was our use case. Fair enough. And then something really cool happened. Spark also brought us Scala. And to be honest, at first, we weren't 100% sure if we should use Scala or Java with Spark. And we were at that time, as I said, a Java shop. We only had Java developers. And well, for the pilot, we decided to go with Scala because Spark recommended Scala. So that's what we did. And what we found was really cool because Scala, as you know, is a functional language in the Java ecosystem. And that meant direct benefits from us. First off, because it's a functional language, the total number of lines of code that you write is way lower. That means that the potential for bugs is lower. That means that the maintenance cost of our project is now way lower. Also, from a Spark perspective, from a big data engineer perspective, Scala is very WYSIWYG in the sense, sorry, I'm borrowing the term from front-end engineers here, but the idea is, as a big data engineer, when you design a pipeline in your head, well, it is, in essence, if you use Spark, the implementation as well. If you know that you need to do a map, then a filter, then a join, then a map, well, that's 4 lines of code. It's a map, a filter, a join, and a map. And so that means several things like faster shipping, faster prototyping, and so forth. And you're still in the Java ecosystem. So you still have the reliability of the JVM, and you still have access to all the libraries and connectors that you're used to. And so Scala really felt like the right tool for the job. It really felt like a hammer to hammer down that nail as opposed to a screwdriver. You can still do it with a screwdriver, but it's not going to be as effective. And I would argue that even with Java 8 and Lambdas, I still think Scala is a better choice because you still get the REPL, you get case classes, you get object, and so forth. We saw a very fast adoption of Scala at Radius. First off, big data engineers didn't have any trouble picking it up because it allowed them to express very simply the complex transforms they were designing. So no problems there. Scala developers that we started hiring also don't have trouble with big data and Spark in particular because they can treat an RDD just as another collection where they do filter, flat maps, and maps. And we saw this kind of virtuous cycle starting where the better you got at Scala, the better you got at Spark, and the better you got at Spark, the better you got at Scala. So that was really, really nice. They feed off each other. And a couple of tips I have for companies that start doing Scala, if you want to have a fast adoption, is number one, keep it simple. Meaning try to avoid developers that are clever. You don't try to be as simple as possible for newcomers, meaning avoid using implicits, keep your SBT very simple, and so forth. The other thing is there are a couple of very important idioms in the functional language world and in the Scala world. They're not necessarily that complicated. They're not necessarily that numerous, and so well, you should have your developer learn them. It's actually quite entertaining, and so I'm thinking about options as collections. I'm thinking about pattern matching and so forth. Once you have that, you will notice that usage of Spark within your company, especially on the big data side, will grow very quickly. Now for us, moving this project of creating this graph of US businesses, the migration took 3 man-months. We did that in January, and 3 man-months to migrate over 100,000 lines of code. I think that's pretty cool. And the resulting code base was 5 times smaller for the same thing. And when I say migration, I mean everything from implementing to testing that it was working properly. So that's great. And if I look at the rewards we have now, we have 5 times more engineers working on the code base than before, and that includes data scientists. Think about it. Before, we required a seasoned Java developer to work on the same Hadoop project. Data scientists that don't have a formal developer training can now help and contribute to the project. Awesome for us. Also, we measured that engineers are now releasing twice as many features as before, now in Spark and Scala. And GraphX and MLlib helped us improve the quality of our graph dramatically. The best testament, I think, to the success of this migration is that the teams that build that graph of US businesses is now in the same release cycle than the teams that does our web app. In the past, those two things were separated. You had the data teams that were creating that graph that worked independently of the web app guys that create the web app and the backend that allow a user to go through segments and stuff like that. And the reason we were separated, it's because first off, we were doing what we thought was the lowest hanging fruit, I would say, but it was based on constraint of the environment. Now, once we moved to Spark and Scala, we were so predictable in how we were doing releases, we were so fast and so accurate that everything has been consolidated into one group, I would say, and with one roadmap, with one release cycle. And that's amazing for Radius because it means it can focus its effort a lot more than before. Finally, all of our big data teams, we have several, moved to Spark and Scala for two reasons. One, we're very successful with this project. And second, we also started using Databricks as notebooks to help exploration of data and stuff like that. And that helped convince everyone that Spark and Scala were really the right tool for the job. And when we look at what we do now in Spark and Scala, first of all, we have, because of the scale allowed by Spark, we process 10 times more records now than before. We have 4 billion records that represents 150 plus billion data points, and meaning we now feed every single historical record that we have about the business in the build to get even richer output. Number one, we do more fine-tuned standardization. This is possible because we can have a lot more engineers working on that project. And that allows us to do very smart things around string similarity functions, around address standardizations. I mean, a lot of complex problems like that. Second, instead of just grouping records when we think they represent the same business, we can actually build a graph and modelize the relationship between those records. This is very powerful because it allows us to do smarter things when we cluster records. And third, because of MLlib and the easiness to impute, classify, regress data points, we get, as an output, businesses that have way more data points than before. So let me say again the takeaways for this talk. Spark and Scala have an amazing synergy. I really urge you to consider using Scala with Spark as opposed to Java. You will get much more out of it. And if you feel right now that your Hadoop project has a high maintenance cost or you're not happy with the rate with which you can ship features, I encourage you to try to migrate to Spark and Scala. Thank you for your attention. Radius is hiring a lot. We have a lot of fun things to do. And if you are interested, you can come and see me after the talk. And if you have questions, please don't hesitate.
Yeah, thank you. Well, awesome. Thank you, Thomas. We're running a little behind, so what we're going to do.